Good morning students. Welcome back to Maths online class. I hope you all have completed your last class assignment. In previous classes we learned about set, representation of a set and types of sets. What is meant by set? A set is a well-defined collection of objects. Next one, representation of a sets. First one, descriptive form. Second one, set builder form or rule form. Third one, roster form or tabular form. Next one, types of sets. Empty set or null set, singleton set, finite set, infinite set, cardinal number of sets, equivalent set and equal sets. Now let's see the continuation of types of sets. Next one, universal set. A universal set is a set which contains all the elements of all the sets under consideration. It is denoted by U. Then a universal set is a set which contains all the elements of all the sets under consideration. For example, if A is equal to set of Earth, Mars, Jupiter, then the universal set is U is the planets of solar system. Then universal set is the planets of solar system. How many planets are there? 8 planets, isn't it? So U is equal to set of 8 planets it will come. Okay. Then for example, another one example. Suppose A is equal to one set, 2, 3, 4. So we can write universal set is U is equal to set of all natural numbers. Then less than 10 or less than or equal to 10. Okay. Then 1, 2, 3, 4, 5, then etc. then 10. Okay. Then U is equal to set of all 10 numbers. Okay. Then A is equal to we can write what? Then 2, 3, 4. Then next one, subset. Let A and B be two sets if every element of A is also an element of B. Then A is called a subset of B. Let A and B are two sets if every element of A is also an element of B. Then A is called a subset of B. We write A is the subset of B. That symbol is like this. A is the subset of B. Or we can say A is contained in B. Then if A is not a subset of B, then we write A is not a subset of B. Then if A is a subset of B, then n of A less than n of B. Suppose A is a subset of B means then n of A is less than or equal to n of B. Then for example, first one, set of 1 is a subset of which one? This set. Okay. Then second one, 2, 4 is given. This one also is subset of 4, 2. Then Third one 5 comma 6. Then it is not a subset of 1 comma 2 comma 3. Here not given, isn't it? So this is not a subset. Okay. Then for example, subset means here A is equal to set of 1, 2, 1, 2 is given. Okay. Then how we can find out the subset of this A? Suppose A is equal to set of 1, 2. Okay, then how we can find out the subset? Then one note is given. If A is the subset of B and B is a subset of A, then we can write A is equal to B. Okay, A all elements in B, like that. B all elements in A means then we can write what? A is equal to B. Second one, empty set is a subset of every set. Okay, then empty set is a subset of every set. Then next one, every set is a subset of itself. Every set is a subset of itself. Okay, so here A is equal to 1 comma 2 is given. We have to use second note. Empty set is a subset of every set. So we can write here one empty set is there. Then empty set, comma. Then we have to write separately. Then set of 1. Next one, set of 2. Then third note, every set is a subset of itself. Okay. Then every set has the subset of itself. Itself means this true number also it will come. Then what are the subsets of 1 comma 2? Null set. Then set of 1, set of 2 and this set of 1 comma 2. Now let's see proper subset. Then proper subset, let A and B be two sets if A is a subset of B and A is not equal to B, then A is called a proper subset of B. And we write A is the proper subset. Symbol is like this. Proper subset. Okay. This is a proper, A is the proper subset of B. For example, if A is equal to set of 2, 4, 5 and B is equal to 2, 4, 5, 6, then A is a proper subset of B. Okay, A is the proper subset of B. Then why means here A is the subset. A is the subset of B, but it is not equal. These two are not equal. Both conditions here satisfy. Okay, this is the subset. A is the subset of this B, but these two are not equal. Not equal. So we can write what? A is a proper subset of B. Then disjoint set. Then disjoint set. Two sets A and B are said to be disjoint if they do not have common elements. Two sets A and B are said to be disjoint if they do not have common elements. If A intersection B is equal to pi, then A and B are said to be disjoint set. Okay. Then A intersection B is equal to null set. Then A and B both also no common elements, equal to or null set. Then A and B are said to be disjoint set. For example, A is equal to one set is given. Here 1, 2, 3. 3. B is equal to another set. 1, 2, 3. 3 is equal to 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 1, 2, 3. 3 5, 6, 7. Then A intersection, this symbol is intersection. Intersection B is equal to, any common elements are here? 1 not given here, 2 also not there, 3 also not there. Okay, so we can write what? No common elements. So we can write empty set or pi. Pi also, this one empty set. Okay, both symbol also we can use. Okay, therefore we can write what? A and B are disjoint set. Therefore A and B are disjoint set. Disjoint set. Have you understood? Next one, power set. The subset of all a set of all subsets of a set A is called a power set of A. Listen, the set of all subsets of a set A is called a power set of A. It is denoted by P of A. It is denoted by P of A. Here, already we studied what a set subset, and A is equal to set of 1 comma 2 means then subset of A is equal to null set, set of 1, set of 2, then set of 1 comma 2 we studied, isn't it? Then from here, how we can find out the power set? Power set means the set of all subsets. Set of all subsets of a set A is called a power set. That means then we can write this one, P of A is equal to set of all subset. This subset fully you should write inside. Okay, then set of null set, then set of 1, set of 2, set of 1 comma 2. Then already here open the bracket, this one close it. Have you understood? Then one more example. If A is equal to set of pi comma set of pi, then the power set of A is, first we have to find out the subset. These are the subset. What are the subsets? Null set. Every element, every set has one empty set is there, isn't it? So we can write then a subset, comma, then empty set, comma, set of empty set, then close the bracket, comma, then set of pi, comma, set of pi, then this set close it. Again already we start open the bracket, this one close it. Once again I am explaining this one. A is equal to set of pi comma set of pi. Okay, then here inside also one set is given, isn't it? Then first we have to find out the subset of A. Okay, so we can write the empty set first, then comma, set of this pi, set of empty set. Okay, then afterwards, then set of this set of pi. Then here open the bracket, here close it. Have you understood? Then afterwards, fully you should write it. Set of pi comma set of pi. Then here open the bracket, here close it. These are the subsets. Okay. Then power set of A means power set of power set of A. That means P of A. P of A is equal to set of all subsets. Set of all subsets. What are the subsets? These are the subsets. You have to write here. Right? Then pi, comma, set of pi, comma, this set of pi, then comma, this set of pi, comma, set of pi, then this bracket close it, then again here open the bracket, this bracket again you have to close. Have understood? Next one, an important property. First one, if n of A is equal to m, the number of subset of a set A is n of P of A. Number of subset of a set A is n of P of A is equal to 2 power m. M means n of A. Have you understood? And second one, the number of proper subset of a set A is n of P of A minus 1. Okay. Then subset minus number of subset minus 1. That means a 2 power m minus 1. Okay. Next we are going to see the problem. Example 1.6. Insert the appropriate symbol, subset or not a subset in each blank to make a true statement. First one, set of 10, 20, 30. Then dash, here correct symbol we have to write 10, 20, 30, 40. Then second one, P, Q, R. Then here W, X, Y, Z is given. Okay. Then solution, how we can find solution? First question we have to write. First one, set of 10, 20, 30 dash 10, 20, 30 and 40. Since every element of 10, 20, 30 is also an element of 10, 20, 30, 40. Okay. Then since every element of set of 10, 20, 30 is also an element of set of 10, 20, 30, 40. Okay. So we get set of 10, 20, 30 is contain or not contain? Very good. Contain set of 10, 20, 30, 40. And second one, set of P, Q, R dash set of W, X, Y, Z. Here you say, since the element here P belongs to PQR but does not belongs to WXYZ, isn't it? So we can write here which is such. This is a subset or not a subset? Very good. This is not a subset. So we can write since the element P belongs to PQR, but does not belongs to set of W, X, Y, Z. Therefore, we can write what? Then PQR is not a subset. Okay, not a subset of W, X, Y, Z. Are you clear? Next example sum. Example 1.7. Write all the subsets of A is equal to set of A comma B. Here solution. A is equal to given set, you should write it, A comma B. Then what are the subsets? We have to find. Okay, subsets of A are, every set has one empty set is there, isn't it? So we can write this is the empty set, null set. Then next one, set of A. Set of A is the subset of this A. Then next one, set of B. Then that set itself, you should write it. Okay, set of A comma B. These are the subsets of A. Have you understood? Next one, example 1.8. Verify whether A is equal to set of 20, 22, 23, 24 and B is equal to set of 25, 30, 40 and 45 or disjoint sets. Then solution. What is meant by disjoint set? A intersection B is equal to empty set means that is a disjoint set, isn't it? So we can find A intersection B is equal to set of 20, 22, 23, 24. A set first we have to write. Then afterwards this intersection, symbol is intersection. Then B set is 25, 30, 40 and 45. Here any intersection? No, isn't it? 20 not given here, 22 also not given, 23, 24 is not given. So, then equal to this is null set or empty set. Okay, since A intersection B is equal to pi or null set, both also same. Okay, equal to empty set. Therefore, we can write A and B are disjoint set. Disjoint sets. Are you clear? Next, we are going to see the exercise problem. Exercise 1.2, fifth sum. State which pairs of sets are disjoint or overlapping. Disjoint or overlapping. Then first one, A is equal to FIAS and B is equal to set of A, N, F, H, S is given. Okay. Then here disjoint or overlapping, here question given, isn't it? Then what is meant by overlapping? If A intersection B is not equal to empty set means that is called overlapping set. Okay. A intersection B is not equal to pi. Okay. Not equal to null set. That means if two sets have at least one common elements, they are called overlapping set. Okay. Then for example here A is equal to one set 1, 2, 3. B is equal to another set 3, 4, 5. Okay. Here A intersection B is equal to any common elements are here A and B? Yes. 3 and 3. Okay. So 3 is common. So A and B are overlapping set. Very clear? Okay. Like that we have to find here. First one. Solution. Here A is equal to. First question. Set of F, I, A, S and B is equal to A, N, F, H, S. Okay. Then A intersection B we have to find. A intersection B is equal to set of F. First A set we have to write F, I, A, S. Then intersection, this symbol. Then B set is A, N, F, H, S. Any intersection here? Any common elements? F is common. Both also common. So F you should write it. Then next one, I not given here. A is there, isn't it? So A also selected. Then S is there. Here also S given. So yes. Okay. Here A intersection B is not equal to pi, isn't it? Not equal to pi. A intersection B is not equal to empty set. So we can write what? Therefore, A and B are overlapping sets. Overlapping sets. Second one, C is equal to X such that X is a prime number, then X greater than 2. X such that X is a prime number, that X is greater than 2. Okay. Here which form is given? Set builder form is given. Very good. Then here this one also set builder form is given. First we have to convert into the roster form. So C is equal to, first we have to find X such that X is a prime number greater than 2. What are the numbers? 3, 5, very good, 7, then 11, 13, etc. Isn't it? Okay. Then D is equal to set of X such that X is a even prime number. Even prime number means 2 is the even prime number. So we have to find C intersection C intersection D is equal to any common elements are here? No, isn't it? So this is null set. So we got C intersection D is equal to pi, null set. Therefore, we can write C and D are disjoint set. Disjoint set. Have you understood? Next subdivision 3. E is equal to set of X such that X is a factor of 24 and F is equal to set of X such that X is a multiple of 3, that X less than 30 is given. Okay. Then E is equal to X such that X is a prime factor of 24. What are the prime factors of sorry, x such that x is a factor of 24, isn't it? What are the factors of 24? Now you see, third one, is equal to set of, what are the factors of 24? You say, last year you learned, maybe, and you say 1, 2, 3, 4, then 6, 8, 12 and 24. These are the prime factors, prime factor not, factors of 24. Factors of 24. Okay. Then f equal to set of x such that x is a multiple of 3. Okay. What are the multiples of 3? Here question is less than, x less than 30. Okay. Then what are the multiples? You say 3, 6, 9, 12, then 15, 18, 21, 24, then 27. Okay, here condition what is given? X less than 30. So stop it. Okay, then we have to find E intersection F equal to, here any common elements are given, check it. Here 1 not given here, 2 is not there, then 3 is there, isn't it? 3 common. So we have to write this 3. Then 4 is not there, then 6, here also 6 is there. Okay, 6 write it. Then afterwards 8, 12, here also 12 given. Then next one 24, here also 24 common. Okay, therefore A intersection F is equal to 3, 6, 12 and 24 we got, isn't it? So we can write what? Then E intersection F is not equal to empty set. Not equal to empty set. So we can write, therefore E and F are overlapping set. Overlapping sets. Have you understood? Next one question. In exercise 1.2, sixth sum. Shall I give homework this one? Homework for you, sixth one. If S equal to set of square, rectangle, circle, rhombus and a triangle is given. List the elements of the following subset of S. Okay. And first question is the set of shapes which have 4 equal sides. How many equal sides? 4 equal sides. 4 equal sides. Then what are these shapes are given here? Check it. Then square, isn't it? Square is 4 equal sides. Then rectangle not equal. This one also not equal, isn't it? Rhombus also 4 equal sides, isn't it? So you should write the answer solution. First one, set of square comma rhombus. Okay. Then like that, second one, third, fourth question, you do the homework. I think you all are very eager to do the homework. Today itself complete your works. Okay. Thank you, students.